In this next lesson, we are going to look at 3 different ways that we can have our scene objects move. A couple of them are demonstrated in the sky. I have some parrots that are moving along a path. I have the sky that's rotating around an axis. And then I don't need a path to move an object. In the case of this parrot, I'm just going to give him a vector, and then he's just going to move in a direction. So let's look at all 3 ways that I can move these objects. Okay, we are going to start in lesson 2 for this lesson. And let's start with something we already have done before, which is moving something along a path. So the first thing that we're going to move is those parrots along a path, which we've done before, but let's just practice that again. So if I look for my parrots, they're all in the sky, and let's see if I can zoom in on them. There they are. And they happened to be grouped in a group. So I don't need to specify each parrot separately. I can just grab the whole group, and that's what I'm going to move along a path. So let's go ahead and create a variable for our parrots. And since we're going to have a different parrot, let's call these our flying parrots. And they're going to need somewhere to fly, so let's grab our parrot path. Now, unfortunately, the group class isn't recognized by code, but we can still program to it. We just have to manually switch it to an animated item. Those are the 2 things that I'm going to start moving using a method that we've done before. We are just going to take those flying parrots and use the transition property to find move on path. And move on path takes a JSON object, so we're going to use our curly brackets and specify our path, which is the parrot path, our speed, which they're flying pretty fast, so we'll start them at 5. And we need them to turn as they move along the path, and we do want them to keep repeating so they don't fall out of the sky. Okay, so when I run that, I can look up at the sky and see that they are indeed flying in a path. And that's the only way that we've known how to move somebody is along a path, but we don't actually need a path, a pre-created path to move an item. And we're going to practice that with this little parrot that we have on the beach. Okay, we're going to get him to move, but we're not going to have to create a path for him because he's just going to move straight. So let's find that parrot. That was parrot number 4. And let's zoom in on him. And I'll go ahead and grab his ID. And we'll call him the beach parrot. And for him, I want him to just move forward a tiny bit, but I don't want to miss it, so I'm not going to have him automatically start moving like I did the flying birds. I'm going to wait for the player to click on him. So to do that, I am going to wait for an event, which is an onClick event on this parrot. Okay, and that takes a handler, which I'm going to use a lambda expression. There's my empty body. Okay, but now instead of using moveOnPath, I want to just specify a vector for him to move on. And before we do that, let's go and watch a little demo on how the XYZ coordinate system works in Cospace. So just like in math class, you have a coordinate system and there is an x-axis along the horizon and the y-axis is going up. Okay, the x-axis is positive going right and the y-axis is positive going up. But the xy axis is lying flat on the ground. So what I really need to describe as up is this z-axis. So as far as a perspective of an object, the object is facing the positive y-axis, and the right hand of that object is going to be the positive x-axis, and going up into the sky is going to be the z-axis. So if I take this object that is at a positive x and y location, I can move it more positive in the x direction, or I can move it more positive in the y direction. If I want to grab it and move it up, then it can move up in the z direction. So this is important to understand as we try to move objects, because the direction that they move is always in relationship to the direction that they're pointing. So if I want an object to go forward, I want them to move in a positive y direction. Okay, so let's go back and look at our parrot. We just want him to move forward a tiny bit, and just to make it look interesting, when he moves, I'm going to have him hop. And I want him to be hopping the whole time that I'm asking him to move. Okay, the next thing I want to do is I want him to move forward. Okay, so instead of moving on a path, I am going to give him a vector to move on. So I'm just going to say move by, and move by wants a target. But that target is relative to where that bird is standing in the direction that he's facing. So if I want that bird to move forward, then I want a vector that is only positive in the y direction. So because it's asking for a vector, I'm actually going to create a new object that's of type vector3, and I'm going to send it the arguments 0 for x, 1 for y, and 0 for z, because I don't want him moving up, I just want him to move forward. And then I'm just going to have him move for about 5 seconds. Okay, that is the first argument to move by. No, I'm sorry. That is the first and second argument to move by. And I could stop there, but I actually want to specify one more object, which is called a callback, which means that I can specify a set of actions to happen once he finishes moving, which is exactly what I want to do. And I'm going to start off my lambda expression with my empty argument list, my lambda declaration operator, and then my curly brackets. And that the body of that callback is going to say that once he stops, I want to switch his animation to eating, because I want it to appear that he moved in that direction because he found something he wanted to eat. Okay, let's see what that looks like. So we still have our parrots moving in the sky. But now when I come down and click on my beach parrot, he's going to hop along for 5 seconds. And then he's going to nibble on something, just like my code told him to do. Okay, so the last type of transition is going to be these clouds. Right now, they're not doing anything, but I want them to move in a circle. So again, I don't have to create a path for that because it's going to just rotate around its center. But let's look at what that code needs to look like. So to make the clouds move, I do first need to grab the clouds. And so if I type in clouds, just like the birds, it is grouped. A bunch of single clouds are grouped so that they collectively create an animated object. So when I go and grab their code, I'm going to create my clouds variable. And it created it as a group, but again, I do need to change that to an animated item. Okay, so when I want these clouds to move, I want it to do a transition that is going, a transition that is going to rotate. Okay, and the function is actually called rotateLocal, but let's look at what it takes. It takes, there's 4 actual options. And it turns out I can use the first one because I want to just specify that it's going to rotate around the z-axis, and I'm going to have it rotate in a full circle pretty slow. So I'm probably going to make a very long duration. But let's create my axis. So remember, when I look at my X, Y, and Z, I actually want it to rotate in the sky. So I do want it to rotate around this Z-axis that's pointing up, because the Z-axis is the up and down axis. Okay, so this time my first argument is the vector. So I'm going to create a new vector. I'm going to set the X and the Y to 0, but the Z to 1. And then let's look at this angle in radians. Radians is a way for me to measure the angle in a circle. And if you're probably used to specifying 360 degrees in a circle, but radians would translate that into pi. So the circumference of a circle is 2 pi, which means that 360 degrees would be the equivalent of 2 pi. So it's very frequent that we use this constant called pi. So I'm going to create it so I don't have to remember that it's 3.14. And I like to be a little bit more accurate, so I do put 1415 as my constant for pi. So if I'm down here and I want this to rotate a full circle, then I'm actually going to have to tell it to rotate 2 pi, because that's how much the circumference of a circle is. And like I said, I want it to rotate for pretty slowly, so it's going to take a whole minute or 60 seconds for it to do that rotation. Okay, let's play and see how it does. Yep, when I look up in the sky, now the cloud is rotating. It could go slower than that, but that's pretty slow. Our birds are flying, and our parrot is hopping around looking for food.